Okay, geometric sequence and series, page 1. I'm going to give you some hints on how to do the first page of problems. Before I start, let's just recall that in our investigation, we looked at a geometric sequence, and the geometric sequence started with 2 kilometers on the first day, and then the next day it was 10% more, 2.2, and the next day it was 10% more than that, 2.42, and eventually on the 18th day it got to be 10.11, something like that, right? So in this geometric sequence, R, the multiplier, was 1.1, because the 10% increase would be multiplying by 1.1. U1 was 2, and UN would be any distance after that. So how do you find UN? You take the first number, 2, and you multiply by 1.1 n minus 1 times. So the first number would just be 2. The second number would be 2 times 1.1. The third number would be 2.42 times 1.1 squared. Okay? So that's how you find the first number. And of course, the geometric sum formula, which can be written either this way or this way, whichever is convenient, you can use either one. Doesn't really matter, it's just that the negative sign comes out to be one way and the other way and the other. You can use either one. That we went over what that means in our reflection of the investigation. Okay, so for this first one, it says geometric sequence has the form 4, 8, 6. Okay, so they're already giving you U1, right? U1 is 4. They kind of gave you R. It says find the common ratio. The common ratio is R. Well, let's see. We can find the common ratio by saying that U2 is equal to U1 times R to the first, right? N minus 1. So U2 is 8, U1 is 4, and R we don't know yet. Well, now we just use algebra. We divide both sides by 4, and we find that R is equal to 2. You could also look at this sequence and just say, hey, what's the multiplier to go from one number to the other? It's 2. Okay. Calculate the 20th term of the sequence. The way you would do this is you would use, again, the formula for the term, and you just write it out here. And then you know almost all of these variables except for U20. So we know U1 is 2. We know R is 2. And we know N is 20. Okay, so you could just do that in your calculator, right? This one's a little bit more tricky. If we're going to find the common ratio for this, if you're not very good at fractions, you might not see that what fraction you need to multiply times 6 to get 2. So you might not be able to do this one in your head. You might have to use algebra. So let's say U2 is equal to U1 times R to the first. So U2 is 2, U1 is 6, and R we don't know yet. So R is equal to, divide both sides by 6, 1/3. Okay, 2 divided by 6 is 1/3. Okay, calculate the 10th term of the sequence. Okay, then we would say U10 equals U1 times R to the n minus 1. So that would be U1 times R to the 9th. U1 is 6, and R is 1/3 to the 9th. And you can do this in your calculator, especially if you have fraction mode on, and I'll show you how to get in there. It's also even easier. You just go mode, and then we look for, let's see, yeah, we go to our answers and we say fraction, and then it'll leave your answers in fractions. Okay, geometric sequence has the form 1280, negative 640, 320, negative 160. Now that's kind of unusual. It's flipping from positive to negative, positive, negative. That's the weird thing about geometric sequence and series. You can have sequence and series that go from positive to negative numbers. And the reason why that happens is because sometimes your multiplier, R, is negative. And if you have a negative multiplier, it'll flip the term from being positive and negative alternately. Okay? So we know that the common ratio is negative, but we don't know exactly what it is yet. So we just use algebra again. And we have negative 640 equals 1280 times r. And so r is equal to negative 640 divided by 1280. And you can do that on your calculator, but you can see here probably that it's negative 1/2 already. Okay. Now let's find the 8th term of the sequence. U8 is equal to U1 times r to the 8 minus 1, which is 7. Okay. And of course U1 is 1280. And r is negative 1/2. And this is to the 7th. Okay. And be careful because you need to put parentheses around the negative before you take the exponent, otherwise you might get the wrong answer. Geometric sequence has all its terms positive, and you might wonder why it's saying that, but we're going to see that in a second. The first term is 5, u1 equals 5, and the third term is 20. u3 equals 20. So u3 is actually equal to u1 times r squared, right? N minus 1. So that would be 5 times r squared. 20 equals 5 times r squared. So let's see. This is a little bit trickier than the one before because before we had u2, now we have u3. But we can still divide by 5 on both sides, and we'll get r squared equals 20 divided by 5, which happens to be 4. Oh, now we have r equals, and then r is like the square root of 4. But we need to be careful here because, like, what can you square and get 4? You can square negative 2 and get 4. You can square positive 2 and get 4. So r can be either one of these numbers. We don't know for sure. Oh, but wait a second. It says that all the terms are positive. So then we know that r has to be positive 2, so that all the terms are positive. If we have a negative multiplier, remember, just like the previous example, it bounces between positive and negative values. And it already said that all the terms are positive, so we know the answer is positive 2. So we found the common ratio. Find the 7th term of the sequence. So then we just do u7 equals u1 times r to the n minus 1, which is 6. And, u1 is 5, r is 2. You can do that in your calculator. Second term of a geometric sequence is 18, and the 4th term is 81 over 2. Okay. All the terms in the sequence are positive. Now we know why they're saying that, because like in the previous problem. Calculate the value of the common ratio. Okay. This is a little bit trickier because if we use our formula, we don't know what u1 is. But they do give us 2 values on the geometric sequence. So we could say u2 equals u1 times r to the 1, and we could also say u4 equals u1 times r to the 3rd. And we know these values. And through that, we can figure out u1 and the common ratio, because we have, look, we're going to have 2 equations and 2 unknowns. With 2 equations and 2 unknowns, we can solve for both unknowns. So first we'll put 18 equals, we don't know u1, and then times r. And then we'll put 81 over 2, and we'll put u1, which is, we don't know, and then r cubed, which we also don't know. Now we're going to solve for u1. So we'll put u1, and we'll divide both sides by r, and we'll get 18 divided by r. And then over here, we'll put 18 divided by r. We'll put it in for u1. So instead of u1, we're going to put 18 divided by r equals 81/2. And then you can see that's r cubed divided by r, and then that leaves r squared. So now we have 18r squared equals 81 over 2. Now we're going to divide both sides by 18. So now we have r squared equals 81 times 2 times 18. And you may not be good at reducing. You can start using your calculator now, but you can reduce this. 81 is 9 times 9. 18 is 2 times 9. The 9's cancel out. You're left with 9 divided by 2. R squared equals 9 divided by 4. Okay. 9 divided by 4. And now you take the square root of that. R could be positive 3/2 or negative 3/2. Both of those squared give you 9/4, but we know that this sequence is all positive, so we know that it has to be r equals 3/2. So that was part A, which was quite long, right? Now to find the 8th term, you just use the formula U8 equals U1, which we didn't figure out, but it's U1 is equal to 18 divided by R. Okay, so it would be 18 divided by negative 1.5. And then, so we know U1, we know R, and it's to the 7th. So it's pretty easy to figure out now U to the 8th. The hard part was just figuring out the common ratio. Okay, so that's it for page 1.